Welcome to the Geometry Topic 1 notes. We're going to review solving equations. And basically, when you're solving an equation, the goal is to get the variable alone. You'll often hear people say, isolate the variable. And the way we want to do that is we want to undo any operations that are happening to the variable. And so we do that by using inverse operations. So like the inverse of adding is subtracting, the inverse of multiplying is dividing, and so forth. There are a couple steps that you do really want to follow so that we would always get the same answer as somebody else. The first thing is look for the distributive property. We're going to talk about that in a second in case you've forgotten what that is, but you want to distribute first. After that, after you've distributed, what you should do is you should check to see if you can combine any like terms on the same side. If you have done that, those two things, and you have any variables that are on different sides, is you want to cancel one set of variables to get all variables on the same side. And when you cancel one set of variables, you'll do that through either addition or subtraction. And this allows you to collect all the variables on the same side. After you've done that, you would want to cancel any addition or subtraction by using the inverse operations. And then after that, you would cancel any multiplication or division. And that should allow you, let's see if I can spell that right, that would allow you to have your variable completely isolated. Now, to see the distributive property is when a constant multiplies a variable or multiplies parentheses with multiple terms inside. It might look something like this: -3 times 2x plus 7. You'll probably remember it when you see those markings, which are great ways to help us understand that we are multiplying. Make sure we're multiplying. You want to multiply the 3 times the -2x and the negative 3 times the 7. Sorry, the -3 times 2x and -3 times 7. And that's an example of using the distributive property. When you combine like terms, very, very, very important. In order to combine like terms, the terms must be on the same side. They absolutely must be on the same side of the equal side in order for us to do this. So you might have something like this: 3x plus 8 minus 11 minus 14x is equal to 7x plus 21 minus 2x. You can only combine like terms if they're on the same side. Now, like terms are going to be terms that have the same variable to the same power. The same variable to the same power. So, for example, I've got the 3x and a -14x on the same side. I'm going to combine those. I'm not going to include the 7x and the -2x on the other sides because we only combine on the same side of the equal sign. So 3 minus 14 is -11. That tells me how many x's I have. I'll also combine the constants, which are considered to be like terms. 8 minus 11 is -3. I could also then combine on the other side the like terms. So the 7x can combine with the -2x. 7 minus 2 is 5x. And then the 21 has nothing to combine with. Please notice I'm not combining the -11x with the 5x. They're on different sides of the equation. So if you have equations that have variables on both sides, after you've gone through your steps, now we're probably looking at like step 3, you want to cancel one set. And this will allow you, you're going to do this through addition or subtraction. This will allow you to get all your terms on the same side. So like if I just kind of start off with the one I was last working with, after combining all of the like terms that were on the same side, I now have variables on both sides. We want to collect all of our variables together on the same side. You could do this in two different ways. One way could be to cancel the -11x by adding 11x. First rule of algebra: whatever you do to one side of an equation, you need to do to the other. And that would allow you to collect all your terms on the same side. Now that's not the only way to do it. Alternatively, what we could have done, let's get rid of all of that. Oops, get rid of it. There we go. is I could have canceled the 5x. This is a positive 5x, so I'd cancel it with subtracting 5x. This equation looks slightly different than the last one that I wrote. However, it's considered to be equivalent and would in the end give you the same answer. So now we're going to go ahead and practice using all of these things. Using our steps, we will do a handful of examples on the front as well as some on the back. Okay, and we'll stop at the back of this page. All right, so for number 1, there is no distributive property. There are no like terms on the same side. There are no variables on different sides. So I'm going to move to step 4. I'm going to subtract 8 from both sides, rewrite this, hopefully by subtracting properly. We'll see how that goes. And then I'll divide by 5 to get that x is 13. Not all answers will be whole number answers. Don't let that cause problems. Okay. All right, number 2. Going in order. First, I would look for the distributive property, which there is none. Then I would combine any like terms, which I do have like terms that are on the same side. I'll combine the 4x and the minus 7x. 4 minus 7 is negative 3x. And then I will combine the 20. Oops, thought I was highlighting. And the 42. 20 plus 42 is 62. And that equals 90. I'll now work on solving the equation, so I'll subtract 62 from both sides, rewrite, and then I'll divide. Now, sometimes when you do these problems, now notice I'm dividing by negative 3. That's because x is being multiplied by negative 3. You divide by the exact same number you're multiplying by. I could leave this as a fraction because it's not divisible evenly, or I could use a calculator and I could write this as negative 9.3 repeating. Your choices are both great answers. Number 6, step 1 is to check for the distributive property, and this one actually does have the distributive property. This is a multiplication action. 30y minus 24 is equal to 23. I'll then add 24 to both sides. You'll see that as time goes on, your geometry teacher will probably show less of the algebra steps and do more in their head. So you guys can start practicing that. I'll now divide by 30. That won't go in evenly. I'll leave it like this. Now, if I wanted, I could make that a decimal to 1 point something. I don't happen to have a calculator right here, so I'll leave it like that. All right. I'm going to pause the video and let you guys try these next 3, and then when you're ready, you can go ahead and you can restart the video. Okay, so pause the video, try these 3, and when you're ready, restart. All right, so for number 13, I'm going to distribute the negative 2. Watch your signs here. A negative times a negative is a positive. Cancel subtraction with addition. Now, a negative 10 is still a minus 10. So notice that that's being canceled with addition. And then last step, I'll divide, which sometimes we don't show that in our work. We just jump to the answer. There's nothing wrong with getting something that is not going to go in evenly. It'll happen often. So a little over 1. Number 5, I'll subtract the 23 from both sides. Rewrite this. And then divide. And sometimes things will go in evenly. Watch your signs. If needed, use a calculator to help you. This is negative 7. Number 6, I've got variables on the same side that need to be combined. So I'll combine that to say 7b, and I'll also combine the constants. Minus 7 is what that will combine to, equals 30. I'll add 7 to both sides. You could write plus 7 plus 7. We're going to try and wean you guys off that. And then I'll divide both sides by 7. Doesn't go in evenly, so b is 37 over 7, or a little bit over 5. All right, number 7. Some of these have variables on different sides of the equation, which is the last thing we want to practice today. If your variables are on different sides of the equation, you actually cannot combine them. You want to cancel one of them. You can pick. I usually pick the smaller one. It doesn't technically matter. It'll work out the same either way. And so you notice I canceled that through subtraction. I'm now going to subtract 8 from both sides. I'm not going to write it, but that's what I'm doing. I'm subtracting 8. And now I'm going to divide both sides by 2. Now, if you need to show those extra steps that I didn't, you can do that. If that's going to help you and you're not quite ready to not show that, that's up to you. We'd like to move you away from that because when you get to Algebra 2 next year, you will not see those extra steps written. So it'll be better for you if you can get used to that. All right, number 8, we're going to start by the distributive property. So I get negative 12d plus 6. That's easy to miss up that sign. Watch out there. A negative times a negative is a positive. Equals 7d plus 31. Since my variables are on different sides, I'm going to cancel one set of them. We could cancel either set. I like to cancel the one that's smaller, and all negatives are smaller than positives. This is not the only correct way to do this problem. So 6 is equal to 19d plus 31. I'll subtract 31 from both sides. You can show that work if you want. And then divide by 19. That's not going to go in evenly, so I'll just leave that as a fraction. Number 9. Number 9, the first step is where most people get stuck. It's very common for people to do 5 plus 4 is 9. But if we think about the order in which we're supposed to do things, we need to distribute first. We don't actually get to combine like terms until after we've distributed. So doing 5 plus 4 is combining like terms. I don't get to do that yet. I have to wait until after I've distributed. So I'll distribute first. There are actually 2 different places to distribute on this problem. Let me rewrite this as 5 plus 32 minus 12y equals 10y plus 5. Step 2 says to combine like terms. I now can combine any like terms that are on the same side. Notice that 5 is now being combined with something, but it's not 5 plus 4. It's really 5 plus 32. Very important that I do this in the correct order of operations. So if I rewrite this, I have 37 minus 12y equals 10y plus 5. Notice I could not combine the negative 12y and the 10y. They're on different sides. What I'm going to do now is I'm going to cancel one set of variables since I have variables on both sides. And I'll rewrite this as 37 is equal to 22y plus 5. I'll subtract 5 from both sides to get 32 is equal to 22y, and then I'll divide. Now this one does not go in evenly, but it can reduce. Both these numbers are even, so I'm going to divide both the numerator and the denominator by 2 to simplify this fraction, reduce down this fraction to its smallest terms. So y is 16 over 11. Or 1 and 5/11ths, or it's like 1.5 something. All right. Pause the video, try 10, 11, and 12. When you're ready, restart the video, and you can check your solutions. On number 10, I do have to distribute, so I get 16x minus 20 is equal to 23 plus 16x. Well, that's really unusual. You might notice there's a 16x on both sides. When I cancel one of them, because that's what we're supposed to do when there's variables on both sides, I get this really odd answer. This says negative 20 is equal to 23. That's actually not true. Not true at all. That's a false statement. Anytime you get a false statement, then what you can know is that there is actually no solution. No matter what number I would put in for x, I could try every number in the entire number system. I would never be able to get a true equation. This is an impossible problem. It's false. So we would call that no solution. This is the symbol for no solution if you'd rather use that. Number 11, I'll start with the distributive property. And I do want to be careful here. When I distribute on this right-hand side, I'm not distributing a 4. I'm actually distributing a negative 4, so I will be careful there. All right, so I would have 21c minus 28 equals, now I do not get to combine that 2. This kind of reminds me like question number 9. Okay, remember the 5 plus 4? This is the same idea. I need to distribute first. I'm just going to record the 2. Negative 4 times 5 is negative 20. Negative 4 times 6c is negative 24c. I will now combine any like terms that show up on the same side. And everything else I'll just rewrite. 21c minus 28 equals negative 18 minus 24c. You can use a calculator to help you with that. Because my variables are on different sides, I'm going to cancel one set of them. I like to cancel the negative 1 if I have a negative 1. You cancel that through the opposite or the inverse operation. Notice I'm adding. So I would get 45c minus 28 is equal to negative 18 I'll add 28 to both sides. I'll show that step here. This is a little bit of a tough problem. Use the calculator to help you with negatives if you struggle. And then I'll divide. Now, if I want to leave this as a fraction, I can, but I would need to reduce these by 2. I could also make this a decimal if I wanted to use my calculator. That's 2.5. Last one, number 12. There's nothing to distribute, so I cannot do step 1. Step 2 says to combine like terms, so I will go ahead and combine 6w minus 2w is 4w, and then I'll record everything else. Nothing else can combine. Things on different sides cannot combine. Since the 4w and the 5w are on different sides, I'm going to cancel one set of them. You could choose which one you cancel. It technically doesn't matter. I like to cancel the smaller one. It is not the only correct way to do that. 5y minus 4y is 1y. I usually don't write the 1. And then I'll add 1 to both sides to continue isolating w. And I'll get w is 41. And that is the end of our notes for topic 1.